Okay, so today we're going to talk a little bit about the periodic table of elements. You have already been practicing the periodic table. By now we have memorized 1 through 20 with the atomic number, the symbol, and the name. Today we're going to talk a little bit about electrons and electron configuration. Well, we're going to begin talking about electron configuration, but you probably see on periodic tables a lot of times the numbers 1, and let me try to make it where you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you see 13, 14, 15, 16, 17, and 18 across the top. This tells you some information about the columns, which column number it is in. We talked the other day when we colored the periodic table about the family names. We had alkaline metals, alkaline earth metals, transition metals. We just called this the boron family, the carbon family. We had pnictogens, chalcogens, halogens, and noble gases. But then you need to know these group numbers. Lots of times, like when I was a kid, we would have Roman numerals at the top of the column, but we really just need to know the group number. So these used to be Roman numerals when I was a kid, a million years ago, right? But we are going to just number them, and these are their group numbers: 1, 2, 3, 4, 5, 6, 7, and 8. These numbers tell us how many valence electrons. So you probably want to write this on your periodic table so that you can keep track of this. The valence electrons, so you might be thinking, well, all right, that's a nice brand new word. The valence electrons are the electrons on the outermost energy level. Okay, so we're going to go to the notebook for just a second, and we're going to look at what does that mean for valence electrons. Before we go to the notebook, actually, let's kind of discuss one more part of the periodic table. We talked about energy levels. You need to remember that the periods 1, 2, 3, 4, 5, 6, 7 tell you how many energy levels are needed for every element. So you can see, let's see, make sure you can read that. Here's period 1, here's period 2, period 3, period 4, period 5, 6, 7. So the periods tell you how many energy levels. So we'll go ahead and write that here so that you can keep that in your head. Now these are using the Bohr's model to understand energy levels, and that's what we'll kind of be looking at until we get to the orbital model. So how many energy levels, let me finish that sentence, are needed Alright, so I'm going to pull in the notebook right now, and we'll kind of look at some different Bohr models for some of the elements. Okay, so if we, I'm going to get all of this on here for you to see. We're going to look at hydrogen. Okay, let's kind of digest hydrogen. If I have hydrogen, I have 1 proton, because the atomic number is 1. I look at my mass number, that is rounded off to 1, so that means I have 0 neutrons. And if this is an atom, not an ion, then I know that my protons equal my electrons, so I have 1 electron. Alright. So when I go to draw the Bohr model of hydrogen, I have hydrogen here, then I have 1 because I am in period 1, so I need 1 energy level. And in that 1 energy level, I have my 1 single electron. Alright, we'll go ahead and look at helium. I guess I'm using up a lot of paper doing it this way, but when I pull helium over my periodic table, I see helium is atomic number 2, so that means I have 2 protons. I look at my mass number and it's 4, so I need to say mass number minus atomic number. I guess technically this is average atomic mass minus the atomic number. So I have 4 minus 2, that gives me 2 neutrons. And since this is an atom again, not an ion, we know that our electrons must match our protons, so we have 2 electrons. And if I go to draw the Bohr model for this, I have helium, and then I need 1 energy level because I'm still in period 1. So, and I have my 2 electrons. The first energy level can only hold 2 electrons, so let's go ahead and write that in our notes. Then let's go ahead and look at a bigger element. Let's look at carbon. Here is a very common element. We are carbon-based life forms, so we will go ahead and consider carbon. It's in period 2, so we know we're going to have 2 energy levels. I look at carbon, and I know that its atomic number is 6, so I have 6 protons. I look at its average atomic mass is 12, round it off, so 12 minus 6, I have 6 neutrons. And then I look at my electrons for carbon. I know that this is an atom, not an ion, so I have my protons will match my electrons, so I'll have 6 electrons. So if I draw a Bohr model, I have carbon. I have the first energy level, which I know can only hold 2. 1, 2. Then I have the second energy level. Now in this energy level, we have 1, 2, we have 4 more electrons left. So we're going to say 1, 2, 3, 4. And then I have my 1, 2, 3, 4, 5, 6 electrons for carbon. So now let's talk about these valence electrons. On the outer ring of carbon, there is 1, 2, 3, 4 valence electrons. Let's look back at carbon. Notice carbon is in the 4th group. That tells me how many electrons are on the outside. That tells me how many electrons are on this outside ring here. So hydrogen has 1. It only has 1 ring, but that's still the outside ring. Helium is kind of an outlier. It's in group 8, but it has only 2. How does that make any sense? The first energy level can only hold 2. So that energy level is full and has no empty spots. Okay. Alright, so we were just discussing how helium is kind of an outlier. It only has 1 energy level and 2 electrons, but in that first energy level it is full because the first energy level can only hold 2 electrons. When we look at carbon here, we have 4 more spaces available for carbon because the next energy levels can hold 8 electrons. So let's just go ahead and look at neon. Neon is in the 2nd energy level. It's in the 2nd period. So we will kind of go back and forth here. If we look at neon, neon has 10 protons. So we'll write that down right here. If we look at its average atomic mass here, it's 20.1, so we'll round that off to 20. 20 minus 10 is 10 neutrons. And then because neon is an atom, not an ion, we know that its protons will match its electrons, so we'll also have 10 electrons. So let's look at a Bohr model for neon. Neon, the first energy level only has 2 electrons and it is full. And then we go to the second energy level and we'll have 8 more. So 10 minus 2 leaves us 8. 1, 2, 3, 4, 5, 6, 7, 8. So the second energy level is full. All of the seats are full. Alright, so let's kind of digest a couple of pieces of information that we have discussed but that we haven't explicitly written out. So the first energy level holds 2 electrons. The next energy levels hold 8 electrons. When an energy level is full, okay, it is stable or satisfied. We've talked about stability before. So all atoms want full outer energy levels. Just like neon, which is a noble gas. There are no more spaces. So if we come back to carbon and look, we said there are 4 spaces that are available. You can kind of think about them as seats at a table. Notice, this little electron is lonely. He didn't have anybody to talk to at the table. He's sitting here on the side all by himself. So he'd like someone to there. Now, there are lots of people who might say, well, why doesn't this electron just move over there? Sometimes it might, but we'll still have those extra seats at the table. So it's really easy if you start by filling 1 seat on each side, and then you can partner them up. It'll help you to see later on when we talk about bonding.